In this PowerPoint, we're going to look at basic classes and objects. So let's begin with an introduction to classes. With data types like integer, string, and bool, we can represent basic data and perform very basic operations like so. Okay, we can define the variable count as 32 and then add that by 1. But what if we want to represent something that's more complex, something in the real world? Then we need more complex real-world problems. So for example, writing a program to manage nature reserves, and we need to track forests. So let's say each forest has X number of trees, it has a name, it can grow, and it can burn. So representing many forests with basic data types means tracking a lot of separate variables and methods. So we can define our own custom data type, forest data type. Okay, so I repeat that, we can define our own custom data type, which would be forest, and use it like any other data type in our program. So let's talk about encapsulation. Encapsulation is a process of bundling related data and methods into a type. So it makes code easier to organize and reuse. So a custom data type is defined with a class. Okay, so that's what a class is used for. It's where a custom data type is defined. And each instance of this type is called an object. So our learning objectives for this class is to define a class, add members like properties and methods to a class, and then customize access to those members using public and private, and then create objects from a class. So let's begin by looking at making classes, instance and methods. So C# provides built-in data types, we know that, right? Like string. And each instance of the string type has its own values and functionality. Okay? So, and phrase is an instance of the string type. Okay? So we have this variable named phrase. Okay? We're creating a variable of the data type string. Okay, and it's called phrase. So phrase is an example of an instance of the string type. Every string has a length property and index of method. So the resulting values are different for each instance. A class represents a custom data type. In C#, the class defines the kinds of information and methods that are included in a custom type. You can then make instances of that class. So there may be many instances of the same class, all with unique values. So to define a class, you begin with class forest. Okay, forest would be the variable name. So write the keyword class, and then forest, and then in curly brackets. So the code for a class is usually put into a file of its own. And it's named with the name of the class. In this case, it's going to be named forest.cs. This keeps our code organized and easy to debug. So to create an instance of the class. So in other parts of the code, like main, in your Program.cs, we can use the class. So the class is defined somewhere else in a separate CS file. And then we use that class in main. So in main, we make instances or objects of the forest class with the new keywords. So now we use forest. Okay, is the data type, I guess. And F is the variable name equals new forest parentheses. So we could say F is an instance. So F here. So F here is an instance of the forest class. Or F is of type forest. Okay, this is its type. Forest is its type. So the process of creating such an instance is called instantiation. Next, let's take a look at fields. We need to associate different pieces of data, like a size and a name, to each forest object. So in C#, these pieces of data are called fields. Okay, fields are one type of class member, which is the general term for the building blocks of a class. Okay, so here we have in forest.cs, okay, we have the class where we're defining class forest, and in it, in these curly brackets, we have public string name and public integer trees. So this is similar to defining a variable. So you're defining a variable here. The variable is name for the forest, and the data type for name is string. And then you have another variable called trees, and the data type is integer. Okay, so this is very similar to defining a variable. So each field here is a variable. And then it'll have a different value for each object. So let's look at default values. Okay, the value of these fields have not yet been set, so each one has already a default value. Okay, so strings default to null, so this would be null. Okay, this default value would be null, and integers to 0. So the trees default value would be 0, and if there's a bool, it would be a false. So let's look at the conventions. It's common practice to name the fields with lowercase. Okay, so like name instead of name, so not uppercase. Okay, so not uppercase. And then we put public in front of it. We'll explain this later on. So using dot to access and edit field. So once we create a forest instance, okay, so we created a forest instance here, we can access and edit each field with a dot notation. Okay, so this, we've created F here as a new forest instance. So we can access that object's field name by going F dot name. Okay, and then we're changing that from its default value of null to Amazon. Okay, and then now if you write F.name, if you print that, it should print Amazon. So why don't you follow along in Visual Studio with me and write this in and check it yourself. Okay, so next we have F2 is another instance. Okay, and F2's name is Congo. So if you write or print F2.name, it should print Congo. Each instance has a name field, but the value will differ across instances. All right, so right now, a property can plant any value in a forest field, even negative numbers. So we need a way to define what values are valid, and this allows those that are not. So C# provides a tool for that called properties. Okay, because we don't want to have, we want to set some constraints, right? We don't want to have negative numbers, in your forest field, right? In your trees, okay? So let's think of properties like another type of class member. Each property is like a spokesperson for a field. It controls the access, like getting and setting to that field. We can use this to validate values before they're set to the field. So it's kind of like checking the values before we set those values to the field. So a property is made up of two methods. Okay, let's look at those. A get method or getter is called when the property is accessed. And a set method or setter is called when the property is assigned a value. Okay, when you're setting a value, it's called set, and when you're accessing, when you're getting, it's called get. So here's an example of property without validation. A basic area property seen here without validation. So the area property is associated with the area field. Okay. It is common to name a property with the title case version of its field name. Okay, so this is the property. Okay, and this is the field. Okay, again, this is the property area with the capital A is the property. It's associated with the area field. Okay. And the field is in lowercase. So it's common to name the property with the title case version, with the uppercase version of the field's name. Okay? Like name and name, or age and age. Okay, so that would be the field, and that would be the property. Right, so value, remember, is a keyword. Okay, so the set method above uses the keyword value, which represents the value we assign to the property. Okay, so here set area equals value. So this represents the value that we assign to the property here. Anyway, back in the Program.cs, when we access the area property, the get and set methods are called. Okay, so here we have an instance of forest f, okay, and then we call f the property, okay, -1. So we are setting -1 to f's property area. Okay, so when we print that, it's going to print -1. So when set is called, okay, the value variable is -1. So area is then set to -1. Now with the validation in the set method, okay, so now let's go take a look at the validation. So here's the same property with validation in the set method. So where is it? So there it is. So here's the set method, and we have validation in there. If we try to set the area, okay, to a negative value, so if value is less than 1, then area is going to be 0. Okay, otherwise the area is the same as the value of value. Okay, so basically what you need to know is that we're setting it so that if value is less than 0, okay, when you're setting it, then the area should be 0. So in Program.cs, okay, when you set f.area, the property, as -1, set is called and prints 0 because -1 is less than 0. So it just sets it as 0. So it might have felt tedious to write the same getter and setter for the name and trees property. So C# has a solution for that. The basic getter and setter pattern is very common. So there's a shorthand called an automatic property. Okay, so here we have an automatic property. So public string size, this is the field. Public string size, this is the property. So you get Okay, and then return size, and you set size equals value. So you don't have to write out the get with the parentheses and set with the parentheses methods. And you don't have to define a size field at all. Okay, so you write public string size and just get set. So that's what it would look like. All right, so far we've built fields to associate data with the class and properties to control the getting and setting of each field, right? So right now, any code outside of the forest class can sneak past our properties by directly accessing the field. Okay, so for example, f.age, the property of f, the property age of f is 32, so using property, right? So here f.lowercase h equals -1, you're using field. So this avoids the properties validation by directly accessing the field. Okay, so using access modifiers, public and private. So public, so we've looked at this before, but we haven't really talked about it. So public, you use that when it's a public member that can be accessed by any class. Private is when you want it to be a private member, that can only be accessed by code in the same class. Okay, so far I've been adding public to every member. This allows the code to access the members from the main method, which doesn't belong in the forest class. So when we switch a field from public to private, it will no longer be accessible from main. Okay, although the code inside the forest class, like the properties, can still access it, but from main, you will no longer be able to access. Okay, so access modifiers can be applied to all members of a class. So you can put private and public on all members of a class, like fields and properties. Public and private are necessary to encapsulate our classes. You're protecting the inner mechanisms of a class with private, so other code can't break your class. You only expose what you want to be public. So since a class's properties define how other programs can get and set its fields, it's good practice to make fields private and to make properties public. Okay, I repeat, make the fields of a class private and make the properties of a class public. C# encourages encapsulation by defaulting class members to private and classes to public. So the get only properties. Okay, so previously we used properties for field validation by applying public and private. We can also use properties to control access to fields. Okay, if we want programs to get the value of a property, but we don't want programs to set the value of the property, we just want it to get it but not change it, not set it, you can don't include a set method or make the set method private. Okay, so not including the set method, just putting get. We can still get the area, but when we try to set the area, we get an error. Next, methods. This is the third type of member in classes. So you've learned that methods are a useful way to organize chunks of code to perform a task, right? Methods are used to define how an instance of a class behaves. So think of them as actions that an object can perform. So an example of a method is here. The method increaseArea changes the value of the area property. Okay, so you have the class forest, okay, and then you have the field, you have the property here, public, which is public, and it's an integer. This is the field area, okay, and we have public, integer, and this is the method increaseArea, okay, and the method is area is area plus growth, and then you return area. So you're adding the growth to the area. So the method is called increase area. Okay, so you would call the method like so. All right. So in main or in your program.cs, in main you would here create an instance, new forest. That's an F, and then you have the result here. You're setting the variable result, and you're calling it by f dot, okay, which is the variable name. Sorry, not the variable name, the new object name. And then you add dot, and you call the method dot increase area. And then you have an argument here, 2. Okay, and then you write the result. So you're going to increase the area by 2. So in the examples, we created a new forest object and set the property values one by one, right? You can write a method that's run every time an object is created to set those values at once. Okay, so C# has a special type of method called a constructor that does that. Okay, it runs every time an object is created to set those values at once. And you do that using a constructor. So a constructor looks like a method, but there's no return type listed. And the method name is the name of its closing class. End closing class. So this is the class forest. And this is a constructor, which is a type of method. Okay, there's no return type in here. Okay, and note that the method name is the same name as its class. Okay, so that's what a constructor looks like. So setting values to fields, you add code in the constructor here to set values to fields. Okay, so this constructor method is used whenever we instantiate an object with a new keyword. Okay, so a constructor is called here. Okay, so forest f equals new forest 400. So this is where a constructor is being called. You can have a constructor without parameters. If no constructor is defined in the class, one is automatically created for us. If it takes no parameters, it's called a parameterless constructor. That's why we've been able to instantiate new objects without errors. So it will look like this. So the parameter for the constructor area looks a lot like the old field area and the new property area. Okay. It's good to be explicit when writing code so that there's no room for misinterpretation. We can refer to the current instance of a class with the keyword this. Okay, so let's take a look at an example of using this. Okay, this dot area equals area means when this constructor is used to make a new instance, use the argument area. Okay, use the argument area to set the value of the new instance's area field. Okay, so again, when this constructor here is used to make a new instance, use the argument area to set the value of this instance's area field. So we would call it the same way. Forest f equals new forest with the value 400 in there. So now the property of f is now equals to, the area property of f is now equals to 400. So class is to instance as a cookie cutter is to a cookie. Let's think of that analogy. So the class or the cookie cutter has used a generic this, okay? Because the class is going to be reused for every instance, okay, or every cookie, right? So just like other methods, constructors can be overloaded. For example, we may want to define an additional constructor that takes one argument, right? So the first constructor provides values for both fields, okay? The second one gives a default value when country is not provided. Okay, now you can create a forest instance in two ways. You can put two arguments in or just one.